Now what I'd like to do is demonstrate how to use SPSS to do a one-way analysis of variance using the general linear model. In this case, what we're going to do is use the Book 2 data, and our variables will be uh, math achievement, which is our dependent variable, and levels of father's education that students are grouped by, which is our independent variable. And so in SPSS, we'll go to Analyze, and this time we're going to go to General Linear Model and Univariate. And for our dependent variable, as I said, that will be math achievement. And our fixed factor, or our independent variable, will be father's education revised. Now, next, what we want to do is specify various information we want in the output. So for the plots, we'll move father's education revised into the horizontal axis, and we'll add that. For post-hoc tests, again, we'll move father's education into the post-hoc test box. And my preference is to use the Tukey test because it's the most conservative in controlling for type 1 error. And then we can also check the game's Howl test because that's what your workbook activity recommends, because we know from the previous activity that the group variances are significantly different. And so the game's Howl post-hoc tests adjust for those differences when determining if there are significant group differences. And then we can go to continue. And one last thing that we want to do is check various options that we want on the output. So we'll take father's education revised and move it into the display needs box. We'll check descriptive statistics and estimates of effect size and observed power. We will cover these topics in class as part of our interpretation of the output. And then we will click on homogeneity tests, and that should do or provide us the information that we want for this particular analysis. And then click on continue, and then click on OK. So in this case, you can see that we have our 3 levels of students within father's education, fathers who have a high school graduate degree or less, fathers who have some college, and fathers who have a BS degree or more. You'll notice that there's 38 in the first group, 16 in the second, and 19 in the third. And one of the things you should always do when you look at your output is to check to make sure these numbers agree with what were in the original data set, because if they don't, that means you coded the data wrong. And then in this table, we have the mean math achievement score for each father's education level, for the students in each father's education level, and the standard deviations. This next part of the output is the Levine's test. And because this is below 0.05, we say that at least 2 variances among the 3 differ significantly. This is our analysis of variance summary table. And in this case, in the general linear model, it's called the test of between subjects effect. The most important row for us to be concerned with is the father's education revised row. And this says that at 2 degrees of freedom, our F statistic is 7.88, and that it's significant at 0.001. So this is well below the 0.05 threshold for significance. And so we can say, based on this analysis, that there are significant differences among the 3 fathers' education levels in terms of student mean math achievement scores. The partial eta square for this particular analysis is 0.184. That's the effect size. And the observed power is 0.945. So I'm going to come down here and we're going to look at the post-hoc tests and see how we interpret those. These post-hoc tests provide us with all possible comparisons between the three groups. For example, if we look at this first set of comparisons, you can see that the students' math achievement scores, or the mean math achievement scores, who had fathers who earned a high school diploma or less, as compared to some college, or students whose fathers had some college, was on average 4.3 points lower in terms of math achievement. Likewise, this group of students whose fathers had a high school diploma or less, as compared to students who had whose fathers had a BS or more, their scores were on average 6.2 points lower. And so we can see that these differences are significant. And the reason we know that is because they're asterisk. So if you see the little asterisk by that comparison, you know it's significant. But you can also look here and see that the probability for this comparison is 0.046, which is below 0.5. So it means that this difference is significant, as well as this probability, 0.001, is also below 0.05. And so both of these comparisons are significant. And then you can look at the other comparisons to determine how those are. For example, you see that students' mean math achievement scores with parents who had some college, as compared to the mean math achievement scores for students whose parents had a BS or more, that difference was only about 2 points in terms of average difference. And we see that that comparison is not significant. The other thing we have is what's called the homogeneous subtests. And what this shows us is that we can see that the students that had whose fathers had a high school diploma or less were significantly different than those students who had a BS or more. But what we also see as those students who had some college did not differ significantly from those students who had a BS or more, because this column is or this mean, I should say, and this mean are the same, and they're both in the same column. So it means that those groups do not differ significantly. And then you can take a look at the profile plots, and you can see, of course, that the high school grad or less group, those students, their mean math achievement scores is certainly lower than some college or BS or more. But you can see graphically that students' mean math achievement scores whose fathers had some college, as compared to those students' mean math achievement scores whose fathers had a BS or more, were just not that much different.